In previous sections, we take the derivative of a functions using the definitions, and then we saw that it is a long process. In these sections, we're going to be using the differentiations formulas to take the derivatives of a function, and which will allow us to do very fast. So the followings are the fundamental, right? I should say like the basic differentiations formulas. And first, the functions f and g are both differentiable at differentiable, and c and n's are any real number. Remember that when we say differentiable, that's basically telling us that the limits as h approaches to 0 of f of x plus h minus f of x all over h, that limit exists. Okay? So the derivative of a constant is 0, because I can show it to you, if it is a constant c, a function is a constant y equal to c, that's basically a horizontal line. And what is the slope of the tangent line on any point on this horizontal line? Is always what? 0. Right? Remember, the first derivative is related to, or we can associate it to the slope of the tangent line, right, on a graph at any point. So derivative of x, that is equal to 1. So in this case, that is a linear function, y equal to x. Derivative respect to x of x to the n power, then the formula tells us you're going to be multiplying with this exponent n times with x to the n minus 1 power. So 1 x power left. Right? So this is a power function. If you have a constant multiple to a functions, then when we take the derivatives, we can simply factor this constant out, right, of the derivative functions. So therefore, this will be what? Derivative as derivative respect to x, right, of constant time of function that is equal to constant time derivative of the function. So you can take the derivative of function first, and then you multiply by the constant later on. And derivative respect to x of the functions, operational functions, f of x plus g of x, or f of x minus g of x, then we can take derivatives for each term, right? Derivative for each term. So that means derivative of f functions plus derivative of g functions, right, both respect to x, or derivative of f functions minus derivative of g function, both respect to x. Now, what we need to remember, all right, and more carefully, practice more, is the property the number 7 and number 8 formulas. Number 7 is a derivative of a product, right, of a functions. So when we take derivatives, we take the derivative of one factor first, and then multiply with the other factor, and then adding with derivative of another factors, and then multiply with the leftover factor. So in short, we will remember as derivative of f times g. That will be what? Derivative of f times with g function plus f functions times the derivative of g functions. If you are, starting to memorizing this formula, I would recommend you write down this short part, shortcut part first, and then apply that formula to the problem. So each problem you should write it down, because this can expand it into a product of three functions. So for example, derivatives, if we are talking about derivative of functions f times g times h, then we will be talking about derivative of the first functions times with the other two, plus derivative of the second functions times with the other two, and plus derivative of the last functions, right, times with what the other two. So you can expand it out the same way as in two functions. Now, so the next formula is for the quotient derivative respect to x of the functions f of x divided by g of x. Then what we do is we take the derivative of the functions in the numerator first, times with the functions in the denominator, minus the numerator functions times with derivative of denominator functions, and then denominator function divided by the quantity will be divided by derivative of the denominator square. So in short, to remember it, f divided by g prime, and we will remember as f prime g, right? F prime times with g minus f times g prime all over g squared. So this is a shortcut, format that we want to remember and then use it. So let's try to apply these formula. So part A, example A, we want to take derivative of a constant functions. F of x is equal to what? 5. So properly writing down will be like this. Derivatives respect to x, right? Respect to the independent variable of the functions f of x. And then we're taking derivatives on both sides of equations. Right? And that will, you can denote it as f df over dx, or you can denote it as f prime of x. Right? And that will be derivative of a constant is 0. B. G of x equal to x to the 5th power. So when we take derivative with respect to x on both sides of the equation, right? So this is the power functions that we are taking, right? So power functions, the way that the formula set is what? The exponent will become a factor, so 5 times, and x to the 5 minus 1, right? The exponent will be 1 less factor. So this will give us 5x to the 4th power. That's the derivative of this power function, g function. C. H of x is equal to 1 over x to the 4th power. Now, you can use the quotient rule, right? But the numerator is a constant such that what we can do is we can rewrite these functions. Remember that the differentiation is basically, the definition is what? Simplifying the limit, right? Evaluating the limit. And we know that the limit of original functions and then the limit of the simplified functions are the same. So therefore, before we take the derivatives, we can simplify the original functions, making sure that the domains and everything you check it, right? It's differentiability in a domain. So by saying that for this example C, instead of I'm using the quotient rule, I can change this into what? Rewrite this into a power function, which is, this is simply saying x to the negative 4 power. So that makes it a lot easier and shorter for us to compute, take the derivatives. So now if I take derivative with respect to x of h, right, then I'm taking what? The power functions, which is a lot less work than the quotient functions that we're going to use. So this will become h prime of x, that is equal to, when we take the derivative of the power functions, bring down the power as a factor, times with x to the negative 4 minus 1, right? Always minus 1 on a power. So this will give us negative 4 x to the negative 5th power, or you may rewrite it as positive exponents, depending on how you want to show your answer. D, the functions k of x that is equal to what? Square root of x. So like before, right, we may rewrite this functions because we don't have a formula for how to take the radical, right, derivative of a radical. So we can rewrite it as what? Rational exponents, 1/2 power. So this will become derivative respect to x of the functions k of x. And when we take derivatives on the other side, x to the 1/2 power. So this will become k prime is equal to, bring down the exponent, which is going to be 1/2, times with x to the 1/2 power minus 1, right? According to the formula, x to the 1/2 power minus 1. So my final answer in this case will be 1/2 x to the negative 1/2. So this basically tell us what it's going to go down to what? The square root of x will be in the denominator. So if you rewrite it into positive exponent. Now, let's move into the next example. We have example E. We have p of x that is equal to what? 4x to the 8th power. So when we take the derivatives respect to x of the functions, p of x, and because of these functions, we have a constant multiple. And by using one of the formula, right, taking derivative of this constant multiple is the same thing as, so p prime of x, the same thing as a constant multiple times with derivative of the functions. Now we are simply taking derivative of what? The exponent part, the power. So that will be 4 times 8 times x to the 8 minus 1 power. So this gives us 4 times 8 is 32. And then x to the 7 power is my final answer. So later on, instead of, our goal is not writing step by step. Right now, you need to clearly understand how to use these formulas so that later on we can do mentally. So when we take in derivative next time, it will be just what? Writing down the answer right away, like for this kind of simple cases, that will be p prime is what? 32 x to the 7 power. So mentally, we will be doing like 4 times 8 and then minus 1 to the exponent. Okay. F. So for some of these example in the beginning, I will write it down like, every single step. And then after that, we will skip those. So q of x, this time is a polynomial functions, 3x to the 8th power minus x to the 5th power plus 5. So for this problem, if I write it down step by step, right? And when we take in derivatives respect to x of the q functions, that is derivative respect to x of the polynomial functions on the right. Derivatives of a polynomial functions we can consider as each term as a function, so that I can use sum and difference, right? Derivative of sum and difference into what? Derivative of each term. So by using that property, now I can say that this will be derivatives respect to x of the first term. This is how I can think about it. Minus derivative respect to x of the second term, plus derivative of respect to x of what? The function, a constant function. And from each case, then I can apply again what more formulas. So for example, the first term, I have what constant multiple, so which we already saw that was happening, right? So this will be what 3 times derivative respect to x of what the power function. And minus right here, I can take a derivatives already, so it'll be 5 times with x to the 5 minus 1 power, and plus derivative of a constant is 0. So now for the first term, it will be 3 times, bring down the exponent times with x to the 8 minus 1, right, on an exponent according to the power rule, minus 5x to the 4th power plus 0. I don't need to write it down. So my final answer now, it will become 24x to the 7th power minus 5x to the 4th power. And that will be my final answer. So notice that writing down step by step, it takes times and a lot of writing. So therefore, we want to practice it a few of them like this so that we can clearly see how the formulas can be operated. And then later on, we want to get our answer from, the beginning, the questions, polynomial functions, and all the way down to what here, right away. Right? So that requires practice, right? Now, let's take a look at the next example. G, x to the 3rd power minus x. Okay? That is what the function R. R of x is equal to x to the 3rd power minus x. So this time, I'm not going to write it down step by step anymore. Take a look at how I will take mental math to work on this. So R prime of x, taking derivative on both sides. And I can see that these are sums, so derivative of each term. So the derivative of first term, that's a power. So bring down the power, and then minus 1 to the exponent. Minus derivative of the second term, x, derivative of x is what? 1. And that will be my final answer. So that's how fast we need to, get to before the test. So that requires practice, okay? H, right? Pause it for a second and then see you can do H quickly or not. So the first step on this example H, what I will do is I will rewrite the square root into exponents. So therefore, this will be negative 3x to the negative 6 minus 5x to the 1/2 power. Then we're going to take the derivatives. So when we take the derivatives on both sides, it will be y prime. And this is a sum and difference. So I'm going to take derivative of the first term. I have a constant multiple. So I will write down negative 3 times with, now I will take derivative of this power part only, right? So which will be what? Negative 6, bring down the power, times with x to the negative 6 minus 1. Minus, and then what? 5 times, because the second term also have the constant, 5 times, and then we're going to take derivative of this what? Power function parts, right? And that will become, bring it down 1/2 times with x to the 1/2 minus 1. So finally, my final answer will be 18 x to the negative 7 power minus 5/2 x to the negative 1/2 power. And you may rewrite it everything into positive exponent, or you may leave it like this. Because I have, even though I rewrite it into positive exponent, I cannot simplify any further. If you can simplify, you need to simplify it for like later on purpose, which is we may take second derivatives, third derivatives, so on and so forth. All right, let's continue to the next one, HI. So go ahead and pause and then try it. So example I will rewrite it like the way that I did on the previous example, which I'm gonna try to rewrite this cube root of x squared into 2/3 power and 1 over x as -1 power. Now I can take the derivative much easier. So when I take the derivatives, I will take the derivative of the first term. 4 is a constant factor, right? So I can take derivative of only what? The power function part. And when I take derivatives, bring down the exponent 2 over 3 and times with what? X to the 2/3 power minus 1. And then plus, now I'm going to go to the next term. I don't have any constant multiple, so I can take the derivative of this power functions right away. So that will bring down the -1 exponent times with x to the what? -1 power, right? And then minus 1 according to the formula. Now simplifying this a bit, that will give us 8 over 3 x to the -1/3 plus, or not plus, it will become minus x to the -2 power. And this will be my final answer. Let's take a look at on J. So J, y is equal to x to the 3rd power plus 7x to the 2nd power minus 8 times with 2x to the -3 plus x to the -4 power. So you can, in the past, what I see a student will try to distribute it, and then that will look like a polynomials, right? Everything's in like assignment differences, and then take a derivatives. That takes too long. So what we need to do is we need to use the product rule right here. Right? So in order to use the product rule, the way that I'm going to look at is I'm going to look at the very first factor as a function, and the second factor as another function, so that I can think about this when I take derivatives of f times g, right? According to the formula, we will take the derivative of the first functions times with the second plus first functions times the derivative of what? The second. So this is the approach that we're going to get. So I'm going to write it down step by step for you in this case for this first step, right? And then we can use the shortcut like we've been doing. So when we take the derivatives, right? Derivative respect to x of the y, that will be equal to, we are taking derivative respect to x of this entire function. Okay? So I'm going to try the copy and paste to make it fast. So now this will look like derivatives respect to x of the first functions, which is x to the 3rd power plus 7x squared minus 8. And notice that I use bracket to indicate that this operations times with the second factor, right? 2x to the -3 power plus x to the -4 plus the first functions x to the 3rd plus 7x squared minus 8 times with the derivatives of the second factor, which is 2x to the -3 plus x to the -4. So I'm using this f prime g times plus f g prime. So now taking derivative of the first factor using the shortcuts, right? For the first term, I will use, let me use color code so that you can see what I'm taking derivatives. So when I take derivative of this, that will become a 3, bring down 3, x to the second power. Right? And that's basically what I bring down the exponent. Let me write it down one more step. Right? Times with x to the what? 3 minus 1. And then plus, now I'm taking derivative of the second term. Right? That'll be 7 times. And when we take derivative of the second term, it'll be what? Bringing down exponent 2 times with x to the what? 2 minus 1 power. And then minus derivative of this constant, right? Which is going to be what? 0, right? Derivative of constant is 0. And that is what? Derivative of the first factor and times with the second factor, which is 2x to the negative 3 plus x to the negative 4. Plus, now continuing this, x to the third plus 7x to the second minus 8. And we're going to take derivative of the second factor, which is 2 times, right? And bring it down this power function part, which is negative 3 times with x to the negative 3 minus 1, right? X to the negative 3 minus 1 power. And then plus, now I'm going to take derivative of the x to the negative 4 power. So this will be bringing down negative 4 and then times with x to the negative 4 minus 1. And then close parentheses, right? So after this, what we're going to do is what? Just simplifying part from now. So if you simplify this, this will become 3x to the second power plus 14x minus 0. I don't need to write it down anymore. Times with 2x to the negative 3 plus x to the negative 4 plus x to the third plus 7x squared minus 8. Then multiplying out negative 6x to the negative 4 power minus 4x to the negative 5 power. And then close parentheses. If you want to simplify further, you can change everything into positive exponents, or you multiply it out, and then combine like terms. But it is not necessary unless we need to do more, right? Later on, meaning like if we need to take the second derivative, then that's when we really want to know how to like simplify. Now, I will recommend, even though I say that on the exam you can leave it as to this point, but I will strongly recommend you try to practice on your algebra to make it fast on simplifying part, because that will be come in handy when we go on taking second derivatives and stuff, right? So don't forget to write this down, y prime. So that will be another. So this is like the usage of this product formula. Let's take a look at on K, right? So pause for a second and then try to use the product formulas on K and see you got the same answer or not. So example K, 4x to the second power minus 1 times with 7x to the third plus x. So when we take the derivatives respect to x, then we use the product rule, taking derivative of the first factor, 4x squared minus 1, times with the second factor, plus the first factor, right, times the derivative of the second factor, which is 7x to the third plus x. Now, when we take the derivatives, right, we can take derivatives on each term. So when we take the derivative of the first term, that will become what? 4 times, right, 2 x to the second power minus 1. So x to the 2 minus 1. And then minus derivative of the constant is 0, right? Derivative of the constant is 0. And time was 7x to the third plus x plus 4x to the second minus 1 times with derivative of the second factor will be 7 times, bring down the exponent, which is 3, times with x to the 3 minus 1 power, right? X to the 3 minus 1 power. And then plus derivative of the second term right here, which is a derivative of x, that will be 1. So simplifying it, this will give me 8x times with 7x to the third plus x plus 4x squared minus 1 times with 21x to the second power plus 1. And this will be my final answer. You can multiply it out and then continue simplifying if you wanted to, right? That's perfectly fine, and I will recommend that. Now, let's pause for a second and then try to do L. Right? So for example L, the f functions, the first thing that we want to do is we want to rewrite this 1 over x squared and 1 over x to the third power into negative exponent so that I don't need to use the product and quotient rule at the same time. Right? Now, when we take, this is a product of functions. So when we take derivatives, we're going to take derivative of the first factor, which is x to the negative 2 power minus x to the negative 3 power, times with the second factor, plus the first factor times the derivative of what? The second factor, x minus 2x to the fifth power. So when we take the derivatives of the first factor, I have two terms. The first term, I will write it down what? This is a power formula, negative 2 x to the minus 1 to exponent, so it will be negative 3. Minus, bringing down the exponents, which is negative 3, and then times with x to the negative 1, minus 1 on the exponent, which will be negative 4. So that's how fast like you're going to be using later on, right? And then times with the second factor, which is minus 2x to the fifth, and plus x to the negative 2 minus x to the negative 3, times with the derivative of the first term on the second factor, which is the derivative of x with respect to x, right? So it will be 1 minus 2 times the power function, so bring down the exponent as a factor, times with x to the minus 1 to the exponent, which is 5 minus 1, which is 4. So now if I simplify it, this will become negative 2x to the negative 3 power plus 3x to the negative 4 power times with x minus 2x to the fifth plus x to the negative 2 power minus x to the negative 3 power, quantities of that, times with 1 minus 10x to the fourth power. And this will be my final answer, right? Because I don't need to take the second derivative, so I will leave it and simplified in a factor format. So this is a product rule, right? Let's take a look at on M. So when you look at the M, x minus 1 to the second power. So we have, right, no formula that allow us to use this composition function. This is a composition function, right? You're going to be looking at, f of x as x squared and then h of x as x minus 1. So g of x, that is basically what? F composed h of x. So we have no formula for the composition function yet. So we're going to talk about that, in one particular section, which is called using the chain rule. So therefore, in this kind of problem, at this moment, we only have what? The product formula. So for example, M in this sections, what we need to do is we need to rewrite g of x equal to x minus 1 squared into product x minus 1 and then x minus 1 so that we can use the product rule to take the derivatives of it. Right? So it's a little bit like, tedious at this point, but wait until we learn the chain rule, then this will be a lot easier and faster. So when we take the derivatives with respect to x on both sides of the functions on this one, and we're going to use what? The product rule. Right? So go ahead and then try it out. Pause for a second and try it out, and let's check the answer. So when we take the derivative using the product rule, derivative of the first factor times with the second factor, plus the first factor times derivative of the second factor. So when we take the derivative of the first factor, the derivative of x is 1, derivative of constant is 0. And then similarly, when we take the derivative of the second factor is 1 minus 0. So we are basically adding x minus 2 twice, so it becomes what? 2 times x minus 1. And that will be my final answer when we simplify. Right? Now, let's take a look at on example n. So example n is a quotient. The function is a rational function. So we're going to have to use the quotient formula. The quotient formula basically say that, f divided by g, because we're going to look at the numerator as a functions and denominator as a functions. If you have f divided by g, and if you're taking derivative of that, then what we do is we take the derivative of the numerator functions, which is f prime, times with the denominator functions, minus, right, minus then numerator functions times with derivative of denominator functions, and all over what? Denominator function square. Always write down this shortcut formula before you apply to it. Right? And that way it will help you to remember the formula. So now when we take derivative with respect to x for this function h, right? And I'm going to write it out in an expansion format step by step for this problem. And so this will become h prime of x, that is equal to, now according to the formula, I'm going to take the derivative with respect to x of the numerator function, which is x, times with the denominator function, which is x minus 9, minus numerator function x times with derivative with respect to x of denominator function, which is x minus 9, and all over the denominator function square. So now when we simplify this, derivative of x is 1, so it will be 1 times x minus 9 minus x times, now derivative of x minus 9, derivative of x, the first term is 1, minus derivative of the constant is 0. So it will be x minus 9 quantity square. So when I simplify this, this will be x minus 9 minus 1 minus x all over x minus 9 quantity square. Right? So if I simplify, because of this is easy to simplify, if I simplify it a little bit further, that will be negative 9 over x minus 9 quantity square. And this will be my final answer. So this is a quotient that we use. Right? So pause it for a second and then let's try it out on example O. Right? So when we take the derivatives of this rational functions, we take the derivative of the numerator part, which is x squared minus 1, times with the denominator, minus numerator times with the derivative of the denominator, which is x to the third plus x. So when I take the derivative of x squared minus 1, and this will give us what? 2x, right? Bring down the exponent and minus 1 to the exponent, minus derivative of a constant is 0, times with the second denominator, minus x to the second minus 1 times with derivative of denominator, which is going to be derivative of x to the third, that will be 3x squared, plus derivative of x will be 1, and then all over x to the third plus x to the second power. You can simplify a little bit if you wanted to, but I will not try to multiply it out on the second factor. So my final answer will be, I will simply put it down as 2x, x to the third plus x, minus x to the second minus 1 times with 3x squared plus 1, and all over x to the third power plus x to the third second power. And your textbook answer may simplify it all the way through. So in that kind of situations, once you get to this step, if it is not the same as your textbook answer, you might want to simplify a little bit further, right, to see you got the same answer or not. Now, let's pause it and then try example of P. Okay. So if I'm doing this problem after practicing so many times of writing in applying the formula and writing out everything, and this is how I will approach it. If I take derivatives y prime, then right away I will be thinking about derivative of the numerator. When I take derivative of the numerator, derivative of constant is 0, minus derivative of x is 1, minus derivative of 3x to the second power. So you're going to bring down the power and multiply it. So it'll be 3 times 2 is 6, x to the 1 power, and times with the denominator, minus numerator times with derivative of denominator. That's where I'm going to start taking derivative denominator, which is derivative of x to the 4 is 4x to the third power, minus derivative of 5x, that will be derivative of 5 times 5 times the derivative of x, so it will be 5 times 1, which is 5. And then all over, x to the fourth minus 5x to the second power. So that's how I'm going to be taking the derivatives if I'm doing it fast, after I practice writing down everything. So in this case, then I can basically, put this right here for you. Those are the steps that we can take, right, to write it down. So now continuing this, right, simplifying a little bit, that will become -1 minus 6x, x to the fourth minus 5x, minus 2 minus x minus 3x squared, 4x to the third minus 5, all over x to the fourth minus 5x to the quantity square. And this will be, the practice that we want to get from the problem all the way down to taking derivatives quickly. Now, let's take a look at the next example, which is given as a position function. And we want to find the velocity functions and the acceleration function. Right? So without using definition, this will be a lot faster for us. Right? So our position functions, s of t, that is t to the third power minus 4t to the second power plus 5t minus 6. So this times we're going to be taking derivative respect to the time, right, t. So my velocity functions, that is basically what? Taking derivative of the position function. So when I take the derivatives of position functions, that is derivative of the first term, which is going to be 3t squared, minus derivative of the second term, bring down the exponent and multiply with the constant, which is 4 times 2 is 8, and then minus 1 to the exponent, plus derivative of 5t, it will be 5, because derivative of 5 times the t, that will be 5 times derivative of t, right? And then minus derivative of a constant is 0. So therefore, we got our velocity functions, which is what? 3t squared minus 8t plus 5. Now, we also want the acceleration function. The acceleration functions is basically derivatives of the velocity functions. So taking derivative of velocity functions, that's basically talking about, we are taking, right, this interpretation is this, taking what derivatives of the derivative of a position functions again. So this is basically what position functions taking derivative twice. So acceleration is second derivative of the position function. Right? So that's the interpretation part. But however, we can just take a look at it and then say that derivative of velocity function, which is we are taking derivative of what? This 3t squared minus 8t plus 5. So when I take derivative of that, bring it down, derivative of the very first term, that will be bringing down 2. So 3 times 2 is 6t minus derivative of 8t will be 8, and derivative of a constant, which is 5, is 0. So therefore, I got my acceleration function 6t minus 8. So this is like, usage of a higher derivatives. Then we're going to do the example that we did before in the previous sections, right? Finding the equation of the tangent line. But however, this time it will be a lot easier because we're going to be using the formula instead of definition. So finding the equation of a tangent line to this curve at the point of x equal to 2. Right? So first, to talk about derivatives, to talk about the equation of the tangent line, we need to find out the slope of the tangent line. So the slope of the tangent line, that is basically what? The first derivative of the functions. Right? So taking derivative of the functions, that is derivative respect to x, right, of the function, which is 1 minus x over 1 plus x. So we can use the quotient rule to compute that, right? This is in general, right? So this will be derivative of the numerator, which is going to be 0 minus 1 times with denominator plus x, and then minus numerator times with derivative of denominator, which is 0 plus 1. Taking derivative of constant is 0, taking derivative of x is 1. And all over denominator square, 1 minus x squared. So this, when I simplify it, this will become negative 1 minus x, negative 1 minus x, right? And then when I distributed this, there will be negative 1 plus x all over x plus 1 plus x squared. Simplifying a little bit further, that will give us negative 2 over 1 plus x to the second power. So this is like, the slope of a tangent line at any point, right? So this is like a general formula for the slope of at the tangent point, any point on this curve, right? On the curve of this equation. But we specifically want the slope of the tangent line at what? X equal to 2. So therefore, the way that we denote it is this, right? Find out the slope of the tangent line at x equal to 2. So all we have to do is what? Plug it in this 2 into this general function, general formula for the slope of this function. So this will be negative 2 over 1 plus 2 to the second power, which will give us negative 2 over 9. So now we got the slope of the tangent line at x equal to 2. So we got the slope, but we need to know where the point is, right? We only have x coordinate, we don't have the y coordinate. So therefore, I need to find out functions evaluating at 2. So that means 1 minus 2, 1 plus 2, which is negative 1 over 3. So therefore, now we know all the informations. When x is 2, my y is negative 1/3. And then also we know the slope of the tangent line at 2, that is negative 2 over 9. So using the point slope formula, y minus y1 equal to m x minus x1, we can substitute it, right? All the informations that we have, and then compute for this equation of the tangent line. So that will be negative 2 over 9x plus 4 over 9. So when you subtract 1/3 to both sides, subtracting 1/3 is the same thing as subtracting 2 over 9. So if you 2 over 9, what is left over? And this will be my final answer. Now, continuing to the next example. And this times we want to find out, find the points on the graph of this at which the tangent line is perpendicular to the line of this. So let me sort of like, shows you a diagram so that you can sort of see what's going on, right? Let's say my curve, this curve right here, right? The equation of the curve. Let's say this is going to be my curve. I don't know, right? Let's say that is the curve, right? That is the curve. And then what we are looking for is what? We want to find out the points, right? It could be one or it could be more on this curve, which the tangent line is perpendicular to this line. So the tangent, let's say for example, this line is right here. Okay, it's right here. That's this line. And then we want to find out the tangent line that is perpendicular to this. So that means we have a tangent line that will be perpendicular to this. So we will have a 90-degree right there. That's what basically talk about. So that basically tells me the slope of the tangent line and then the slope of what? This, right? Equations of the line, they are negative reciprocal. Right? So first, what I need to do is I need to find out the general formula for the slope of the tangent lines anywhere on this graph. And then I'm going to use negative reciprocal idea with this. Right? So that's the process. So being said that, first, what I need to do is I need to find the slope of the tangent line in general. So that basically, we need to take derivatives respect to x of these functions, x to the 5/3 plus x to the 1/3. So when I take the derivative, this would become 5 over 3 and then subtract 1. So there will be 2 over 3. And plus 1/3 and then subtract 1 will be negative 2 over 3. So we got this general formula for the slope of the tangent line. And what we are interested in is what? The slope of the tangent line that is perpendicular to this line. So we know that one is perpendicular, that's negative reciprocal slope. So first, I want to find out what is the slope of this line is x plus 2y, that is 7. So my y will be negative 1/2 x plus 7 over 2. The slope of this line is negative 1/2. Since the slope of the tangent line and then this line, they need to perpendicular, so therefore my slope of the tangent line must be negative reciprocal of this, which is will be what? 2. So we need to look for any x value that's going to make, right? Any x value when I plug it into this in general, that will give me what? The slope 2. So we want to look for what is x is. So knowing this, now we need to solve for this, right? We need to find out. Now the question will be, when the slope of the tangent line is equal to 2, now we want to find out what is my x value is going to be. And that's where the points are, right? That's where the points going to be. So that basically means I'm going to set it up the equations like 5 over 3 x to the 2/3 plus 1 over 3 x to the negative 2/3, that is equal to 2. And we want to solve for x from here. So solving this equation is not really pretty, right? And we can basically first clear the fractions. 5x to the 2/3 plus x to the negative 2/3 equal to what? 6. And then what we can do is this is, look at this. This is a negative exponent, right? So I can change it into positive exponents, which is going to be 1 over x to the 2/3. So I can multiply everything by this x to the 2/3 again, right? that will give us 5x to the 4 over 3, right? And then what? Plus 1 equal to 6x to the 2/3. So when I bring this to the other side, it will be 5x to the 4/3 minus 6x to the 2/3 plus 1 equal to 0. And from here, what I can do is I can use the quadratic inform to work on this, which is, you can see that, x to the 4/3, that is x to the 2/3 to the second power, right? So we can use the quadratic inform saying that let u be equal to x to the 2/3 power. So therefore that would be 5u squared minus 6u plus 1 equal to 0. So I will have 5u minus 1, u minus 1 equal to 0. And from here, if I continue solving for it, that will give you 5u minus 1 is equal to 0, u minus 1 equal to 0. So I get u is equal to 1 over 5th, which my u is x to the 2/3, right? Is 1/5. So I can basically find out my x. Similarly, right here, x to the 2/3 is equal to 1. So my x is equal to 1. I got one answer right here so far, right? And then for this one, I can basically raise to the 3rd power and square it, so it'll be 1/5 to the 3/2 power. So we can basically, compute this. But the question is asking for the point where the points are. So I got x coordinate for 2 situations, right? And I need to find out what is my y coordinates, and I'm going to leave that to you to compute that. So I got my x coordinate. I got my x coordinate 5 to the 3/2. You can substitute this into the equations and find out what is my y coordinates going to be, right? By using the calculator. So that part, I'm going to leave it to you. Now, let's move into the next equations, the next example, right? So this is probably the last example. Yes, this is the last example. But to talk about this example, we need to, understand terminology, right? We will go back and look at it. Find the equation of the tangent line and the normal line to the curve at this particular point, right? So tangent line, we don't have a problem. We know how to find it out. But what is a normal line? So let's go back all the way to the beginning of the notes and then take a look at the definitions of it. The normal line to a curve at a point P, that is basically talking about a perpendicular line, right? Perpendicular line to the tangent line at P. That normal line is a perpendicular to the tangent line. So therefore, we know that the normal lines and then tangent, they have negative reciprocal slope because they are perpendicular. So it's not new anymore once we know the definition because we just did that problem, right? So going back to this example. So first, what we need to do is we need to find out the slope of the tangent line. And then once we get the slope of the tangent line at the particular point, then we can get the slope of the normal line because they are perpendicular, meaning it's negative reciprocal. So slope of the tangent line is easy to find out. So first, I'm going to find out in general, which is the slope of the tangent line in general. That's basically taking derivatives respect to x of the function, which is x to the 1/2 power all over x plus 1. You're going to have to use the quotient rule. So using the quotient rule, taking derivative of the numerator, that will be 1/2 x to the negative 1/2. Right? Bring down the exponent and then minus 1 to the exponent. Times with the denominator minus the numerator x to the 1/2 times with derivative of the denominator, which is x, derivative of x is 1, derivative of 1 is 0. And all over denominator square. So if I simplify, a little bit further on this, that will give us 1/2 x to the negative 1/2 times x. That will give me x to the half, because when you add the exponent, and plus 1/2 x to the negative 1/2 power, and minus x to the half, all over x plus 1 square. So that's the general. Now what we want to do is we want to find out the slope of the tangent line at particularly x equal to 4. So that's basically telling us to substitute it in there, right? So when I substitute it, this will be 1/2 times what? Square root of 4 plus 1 over 2 times. When I change this x to the negative 1/2 to the positive exponent, it goes to the denominator, so it will be square root of 4 minus square root of 4, and then 4 plus 1 to the second power. So this gives us 1 plus 1 over 4 minus 2 all over 25. So simplifying a little bit more on this one, right? I can multiply both numerator and denominator by 4, so it will be 4 plus 1 plus 8, minus 8 over 100, which is going to give us, you can use a calculator and get done by one step, which is negative 3 over 100. That is the slope of the tangent line. So once we got the slope of the tangent line, with this point, we can find out the equations. Okay? So now we have what? 4, and then 0.4. That's the point. And then the slope of the tangent line at that point is negative 3 over 100. So we can find out y minus y sub 1 equal to m x minus x sub 1. So that would be y minus 0.4 is equal to negative 3 over 100 x minus 4. So if you want, you can, convert this into decimals or fractions, whatever you want it to, all right? And this is 0.03, so I can say that negative 0.03x, and then plus 0.12, and then y will be equal to negative 0.03x plus 0.52, and that's my slope of equation of the tangent line at that point. Now, for normal line, right? This is a tangent line. For the normal line, we will be talking about at the same point, but however, the slope of the normal line, that is negative reciprocal. So it'll be 100 over 3. So we are talking about the same thing, except what? 100 over 3. So y minus y sub 1 equal to m, x minus x sub 1. So it will be negative 0.4, which is equal to 100 over 3 x minus 4. So that is basically y equal to 100 over 3x minus 400 over 3. And 0.4, when you add 0.4 to it, that is basically 4 over 10. And you can use the calculator to compute this part and then get the final answer. So 100 over 3x, and then what? Get a negative value right here, right? So you can use a calculator to compute it and then fill in this number right here, and that will be the final answer. Now, this is the sections that allow us to compute the derivatives a lot faster by using the formula, right? And the key thing is, as I pointed out, you need to do very well and then get used to with the product rule and the quotient rules and how to manipulate, the functions, right? Rewriting it or simplifying it before you take the derivatives. Do more homeworks.